All right, now the next type of symmetry we were introduced to was called rotational symmetry. Now a figure has rotational symmetry, and I'm going to abbreviate symmetry here, or it's also called radial symmetry, if it can be rotated about a point by an angle greater than 0 degrees and less than 360, so the image coincides with the pre-image. So what do they mean? It basically means that if I was to take this square, and if I'd put its center location on it, if I rotate around that center spot, like on a doorknob, I would get a 90-degree rotation. And now I want to show you something a little bit about rotation. Rotation is done going counterclockwise, and so notice the angles are positive if you go clockwise. Counterclockwise, it's 90 degrees. So if you go counterclockwise, it's actually be a negative 90 degree. I mean clockwise. Boy, let me try this one more time. If you go counterclockwise, your angles are positive. If you go clockwise, your angles are negative. They just tell you direction by that. So just be kind of careful when you do this. So, but if I would turn this very quickly, 90 degrees, I would still have that exact same square. You couldn't tell if it was really any different than that. One thing we talk about it is how we decide. We have what's called the angle of rotational symmetry. It is the smallest angle through which a figure can be rotated to coincide on itself. So if I was looking here, we always think about, and really you can almost think, can I inscribe the figure inside a circle? And so it's like you're turning a doorknob that's round. Like how would it turn inside that circle? The angle of rotational symmetry for this one would end up being 90. How would it be 90? Well, you figure out all of its perfect parts, and you just take 360. And you divide by the ones that repeat, so that's by 4, so that's going to be 90 degrees. The order of rotational symmetry is the number of times that it can rotate and still, before it heads back to 360 to go through, and that's called the order of rotational symmetry, and really that helps you really get the angle and vice versa. And the order of this, because I could turn it 4 times to get to 360 basically, it's going to be an order of 4. Or you could think of it like this: the order is 360 divided by 90, which is 4. So it means they interchange with each other. It's not really a big deal. So let's look at this next page and see how we do this one. On the very first one, we're supposed to decide if it has rotational symmetry. If it does have rotational symmetry, what's the angle of rotation and what's the order that it's going to have? So looking at this one, can I put a point anywhere in the middle of this first one and be able to turn it onto itself? No, I'd have to go all the way around 360 degrees to do that, so my answer would be no. Now on this flag, it's kind of like the Windows symbol, correct? For, well, if you're a PC person. You'd go through, and this one does have rotational symmetry because I could go from here to here and still get the same figure. So that's not all the way around the circle. So yes, it has rotational symmetry. The angle of rotation is going to be the 360 divided by 2. That's going to be 180 degrees. And so that means my order is going to be 2, because that's what I divided 360 by to get my values. So I could turn that 180 degrees, and then I can turn it one more time 180 degrees in order to get that. Now this was a railroad crossing sign symbol. This would not have certain rotational symmetry or line symmetry if I actually had the railroad signs, if I had the R's in there. But since with they're out, we actually have a lot we could do with it. So yes, this has rotational symmetry because this is where I'd put my center point. I'd have 4 equal spots I'd be able to go with, so my angle of rotation symmetry is going to be 360 divided by 4. That's going to be 90 degrees. So that means my order, because I divide by 4, is 4. Now this symbol is a slow-moving symbol. I saw this a lot as a kid. I grew up in the country, so all the tractors had to have them while they were going from their next field and they were on the main roads. And so if I put my point right smack dab in the center, think about it, you really have like this circumscribed circle that surrounds the figure to work with it. I say yes, it does have rotational symmetry. The angle of rotational symmetry is going to be 360 divided by 3 this time, which is 120 degrees. And then my order for this is just going to end up being 3. Now the next one I have is a parallelogram. And normally we don't think of parallelograms have symmetry because they don't have line. This one doesn't have line symmetry. But if I put a spot right smack dab in the middle, I can rotate 180 degrees, and that's under 360, so it has rotational symmetry. So yes, it does have rotational symmetry. The angle of rotation is going to be 180 because that's just 360 over 2. And then I have here my order is 2, because what did I really divide by? The next one we have the scalene triangle has popped up again in this. Is it really, no, it doesn't have line symmetry. Can I put a point in there? Can I go upon itself? No. So this one doesn't have either line or rotational symmetry, so that would be no as well. All right, so we will stop right here and then we'll do the next page together.